Okay, we have our laboratory set up here. You will note we have this structure. There is a shielded line, a shielded conductor, and then down here we have these clasps, gorilla clips are clipped onto the shielded part. And then down here we have something that might be seen as just a solid piece of conductive stainless steel. We have this hooked up to a power supply. This one is a 6-volt power supply. It's on AC mode, and I have 4 ohms of resistance. So 6 volts, 4 ohms means I have 1.5 amps of current load. We could confirm that if I wanted to, but trust me on that. We got 1.5 amps of current load going through this wire. Here I have our magnetometer, and you can see as we get further away, it's going to pick up some reading from the power supply itself. But as we go closer, we're pretty close here. This is on the high end of what this number here, 8.4 in that range. Micro Tesla is approximately what we see when we're under like a high tension power line at 10 meters or so. And that's approximately the EMF there. And you can see as we back away, the EMF goes down. As we get closer, the EMF goes up. Right, as we get very close, it's probably peaked out 13 microtesla. But again, we have this is at 1.5 amps, so we can probably do the math to compute what the amount is there. So now we have an oscilloscope here. It's a cool little handheld oscilloscope, and I've got it hooked up to ground, and we can see, for instance, if we were to touch this here, the voltage is it's higher than 3.6 volts. It's 6 volts, but it's just not, the peaks aren't shown because we are in 500 millivolt range. But you can touch it here and see that it's in 6 volt range because that's what's coming off the power supply. And you can touch down here to say well, what is the induced voltage coming from this line, right, which is shielded, down to here. You can see at this distance, we get about 860 millivolts, and it's at 60 hertz, right, because the power from the AC mains is also at 60 hertz. So this doesn't say anything necessarily about the current density yet, because the circuit here is sort of a strange circuit. But what we can do is we can then attach this to create a circuit and actually measure some of the current load, current density. Anyway, 780 millivolts. Interesting thing, if you measure your own ground to earth, your own ground to earth is actually, let me turn up the resolution here, about 5 volts from me to earth. It's because your body is picking up, your body is actually creating an induced circuit. You're inducing a voltage from the AC in the wall, or AC, the AC coming off the power supply or the line. Switching this off. And even with that off, it's about 5 or 6 volts, and this is the power supply is not even on. It's just the induced voltage coming between the wall and me. Kind of cool.